Thomas will be co-presenting with me for this topic. So I'll be going through the overview use cases, hand over to Thomas for details and caveats, and hand back to me for configuration. Thomas will go through the best practices, troubleshooting, and I'll show you the demo, and Thomas will also jump in for the troubleshooting portion of that. So 10.5, we do not support IPv4 multicast overlay networks. 10.6 CPE, right? CPE, not the initial 10.6 GA. So we found out last minute issue, so we're going to push it back to a CPE release. Most probably January of next year. That's the plan. So we're going to add the support for IPv4 multicast over VXLAN AVPN on these platforms. So what's new and related to this? L2, IGMP Snooping, L3, PIM, sparse mode routing and overlay. So you see both L2 and L3 is supported for multicast IPv4. We're supporting both centralized and distributed gateways. And BSRs and rendezvous points are supported in the VXLAN overlays with caveats. Use cases. In the campus, typically we see receivers as these clients. Right? They're connected to the access switches. And these are distributed gateways. You can see the default gateways are spread across multiple access VTAPs. But I've also seen some of these clients also as sources. So we can support both source and receivers at the access, not a problem. Okay. But typically, if it's like a streaming service, it'll be in the data center. We have your source here, and these are the receivers. This is a more typical multicast setup. Okay, and basically, if it's a different subnet, like you see here, the source is in subnet 10, VLAN 10, your receivers in VLAN 11, subnet 11, and 13, you need to route. Right? As long as it's L3, you need to route using PIM. If it's on the same subnet like this, 11 and 11, you can use IGMP Snooping to block if required. Data center, same thing, different racks. We support both layer 2 and layer 3 multicast across the racks. So source here, subnet 10, you could have receivers on 12 or even subnet 10 as well, or even 11. So let's talk about this IGMP snooping. Right? It basically is used to limit L2 multicast across VTAPs without receivers. So by default, this is not enabled. So what happens is, if a source sends out traffic, VLAN 10, all other VTAPs with VLAN 10 will receive it. That's without IGMP snooping, right? That's default. If you enable IGMP snooping on that VLAN, what happens is, if there's no receiver here, this guy is a host, but it's not a receiver. This VTAP will not send it out. So it will never leave the VTAP because there's no interested receiver, right? So you prevent it. You basically optimize your underlay network with this. But because this is VLAN 12, this is layer 3, you still send it over the L3 VNI for this VLAN 12 with a receiver. But VLAN 10, we do not send it out. So IGMP snooping, that's the use case to limit L2 multicast. And whatever I mentioned is also applicable in the campus. If you have source and receivers on same VLAN spread across multiple VTAPs, this will also help. All right, details. Hand over to Thomas next.
Hi, Daryl. So myself, Thomas Samuel. I work for the multicast development team. So I'll share my screen.
Okay, I see it.
Yeah. Okay, so I'll start with IGMP and IGMP snooping. So since this is a proprietary functionality, what we do, right? So I'll go a bit over details of how the forwarding is happening when you have L2 VNA and snooping enabled. Okay, so in this example, I'm not showing the spine network just for the simplicity. So you can see there are tunnels connected with 3 leaf routers. So being VTAP1, VTAP2, and VTAP3. So the underlying network is you can see those dashed blue lines. Okay, and I have a multicast source and 2 receivers, receiver A and receiver B. So typically when if there are no joins or no IGMP reports from any of the receiver, the Multicast source will not be forwarded to the tunnels, okay, with IGMP snooping enabled. So if the receiver B, suppose the receiver B want to join for a particular group, the source is sending, it will send a membership report, and that report will be forwarded to all the tunnels. Okay, so one copy will go to VTUP2 and another copy will go to VTUP1. And so the VTUP1, once it receives the join membership report, will add this particular interface, this virtual interface, this tunnel interface to the egress port list. So what happens is the traffic will be forwarded only to VTUP3, and and it will not be forwarded to the VTUP2. So now the client on the receiver, I mean on the receiver on the connected to VTUP3 will get the traffic. So this is basically the optimization when we enable IGMP snooping. So we'll move to the next slide. So this is the output of on VTUP1 from the previous slide. So if you want to verify now how the forwarding is happening, so there's this command show IP IGMP snooping on this particular VLAN and for this group. So you can see that under the port to which VTUP the traffic is forwarding. So that will clearly indicate that it will only be forwarded to the VTUP3, which is 3.3.3. So this is how you verify that it's not flooding, but it is actually snooping on the L2 VNI. Okay. So if you have any questions, just give me those questions in the chat window. So we'll try to answer it. So now we'll move to the routing use cases. Okay, so this is basically the symmetric routing use cases using PIM-SM. So IPv4 only is what we are planning to support in this release. So there is zero configuration required. Basically, whatever existing PIM configuration command can be used on supporting the tenant VRF routing. So basically, what I'm saying is, you don't need to configure any other special commands, or no new commands are there. Just the case for a regular standalone devices. But there is changes for VSX cases. We have different commands that will come in the latest slide. So for this is a regular standalone topology where you have here, this is similar to the snooping topology. The difference is that I have an L3 VNI configured on the underlay interface, and I have that overlay tunnels also created. And I have similar to that here, I have a multicast source on the left side and receivers on the top and on the right side, A and B. And the receiver B is basically sending a join. So before that, this PIM, the PIM will basically learn the neighborship via the overlay tunnel. So VTUP1 will see there are two neighbors, which are VTUP2 and VTUP3. So PIM will treat this L3 VNI as a special interface. Okay, so the special interface will be named like the VNI, VNI 635,000, something like that. So if you can see the mroute entry, right? This is similar to this is the basically the interface what we will learn. So on that interface, you will learn typically the neighbors, which are VTUP2 and VTUP3. Now, what happened here is the receiver B want to join this particular source. Okay, so the receiver B sends a join, and that join will be forwarded to this PIM neighbor, which is VTUP1. And VTUP1 will add the mroute entry. And so the output on the VTUP1 will be something, it will look like this, just like our regular PIM, right? You have an incoming interface of VLAN 10. This is a VLAN 10 interface, which is incoming. And we'll have the L3 VNI interface as the egress list. So here the difference between the snooping and the routing is on an L2 VNI, and the previous slides, right? It will only forward to that particular tunnel, that VTUP neighbor. In this case, it will be forwarded to both the tunnels. So in L3 VNI case. So in routing case, we will send the traffic to both the interface. So this is currently what we support, and there are plans to optimize this in the future release. So what will happen is the VTUP3 will see the packet on the L3 VNI interface, and that will be forwarded to the receiver B. So the M route on VTUP3 will look something like this. So if you see for this particular stream, the incoming interface is VNI 6500, and the egress interface is VLAN 30. So this is how the basic functionality of PIM routing happening. Okay, so in this case, I intentionally made the RP. Okay, so RP on the source side only. So here there is no need to register and also. So there are cases where we have RP on a different VTUP than the source. So let's move to the next case where I have the RP is away from the source. So let's say the RP is residing in the remote side of a VTUP. And in this case, what happens is the source need to be registered with the RP. So what just like the hello packet, the PIM register also will be encapsulated and sent to the RP. And the RP will send the rec stop back to the multicast source DR router, which is VTUP1. So basically, the register will go in this way, and it will come back so that the VTUP2 is, which is the RP, is aware of the stream. Then subsequently, when the receiver and try to join the stream, right? So it will send a IGMP membership report, and the join will be the PIM join will then go to VTUP2. Okay, VTUP2 will then send a join towards the VTUP1. So then eventually what happens is VTUP1 will have an M route entry similar to what I have shown in the previous slide, where incoming interface is VLAN here, let's say 10, and the egress interface is L3 VNI. So that egress interface L3 VNI means these two tunnels, right? So the traffic will be forwarded in this direction as well as in this direction. So you'll see an M route entry on VTUP3, and that's how the receiver will get the traffic. Okay, so one of the requirement here is that since registers and all use unicast, internally it use unicast, right? So you need to configure the virtual MAC, okay, on all the VTUPs. So virtual MAC configuration is a must for the PIM register and register stop things to work, right? So let's move to the next slide. So we have now let's talk about the VSX case, which is the major scenario, right? Most of the deployments are like with VSX, right? So in VSX, right? So so I have two slides for this. One is when I have the source connected on the border VSX gateway router, and the second use case is where I have the clients connected or the receivers connected to the border VSX scenario. So in this topology, you can see the VTUP primary and secondary both are having the same tunnel IP, and you have an access L2 aggregator where I have the multicast source is connected. So in this topology, right, what we have to enable is IP PIM sparse VSX virtual neighbor. This particular configuration we have to enable on all the downstream VLANs where it is interfaced with the external network. Okay, so this is the command which we need to ensure that we have enabled on all the VSX pairs. And so working principle is more or less same like what I have told earlier. So what happens is the receiver will send the join. Okay, so PIM join will be sent to the VTUP1. So when you see here, both of them have the same IP, right? So it's almost like an ECMP path to reach the IP. So it can either land in VTUP1 primary, or the join will land in secondary. So let's assume that if it is coming to the secondary, so we have a syncing mechanism where all the joins will be synced to the primary. Okay, so what happens is the join will go to the primary, and so if suppose it is coming to the primary, then it will be synced to the secondary. So in that case, in that way, both will be aware of the join. Okay, and what happens is, both the primary and secondary will add that interface to the O list. Okay, so the traffic and what happens is only the primary will be the forwarder for the traffic. Okay, the secondary will keep the interface ready, but it will be just like a backup role. So the secondary will become active only when the primary goes down, or primary is down. Okay, so for this reason, right? So for syncing and all, that keep alive L3 connectivity is preferably required, and it need to be a point-to-point connectivity. Like it is preferably better to have a point-to-point keep alive connectivity. Okay, because the PIM messages are synced using those L3 connectivity links. Okay, so that is how it happened when you have a source connected to L2 access. So next, go to the receiver case. So this is same topology like what I shown before. The only difference is you have the receiver on the L2 access switch, and this side is the inside the fabric, and what you can see, this is L2 access and all, it's outside the fabric. And what happened is the join, right, primary and secondary. Since that command is again, you need to configure the VSX virtual neighbor on both the primary and secondary. And the primary and secondary both will send the join to the VTUP, the remote VTUP, and VTUP2 will add this particular tunnel to the O list. So now the traffic can reach either primary or secondary, and whoever gets it right will forward the traffic to the receiver. So in this case, if it reaches primary, the primary will forward the traffic to the receiver. So if it reaches the secondary, secondary will forward. So if you inspect the M route, both will have the interface, this particular VLAN 20 in the O list. So that is how this topology works. So now let's assume we have a topology like this, where we are doing an L3 extension from a non-VSX VTUP. So the VTUP2 here is a regular VTUP box. Okay, so it's a regular leaf. And if you want to connect to an existing L3 network, which is outside the fabric, so this is how it works. So we can reuse the RP there. You don't need to configure any specific RP inside the fabric. You can just reuse. So you can very well configure the RP on VTUP2 also. But if you already have an RP on the existing network, right, we can just reuse those RPs. Okay, so this is like this is again the same thing, VSX case only, but what I am shown here is you can extend the VTUPs with an L3 extension to another site. So earlier what I have shown is an L2 extension in the previous slide, right? I have shown L2 extension where servers and receivers are there. Now this is like an L3 extension. Basically, what means is this primary secondary is the border fabric router, border gateway router, and you have the L3 router at site 1, which you can do an SVI or it's a lag, right? It's a VSX lag, and you can configure an L3 SVI and PIM router on site 1, and you can very well connect the source and receivers on that side, which can communicate to VTUP2 and the site 2 also. So similarly, on the right side, I have another. I just draw both the cases in the same slide just to save time. So what happening here is this is like an ROP extension, like it's an L3 extension only. So from primary and secondary, I have an ROP connectivity to an L3 router, maybe on the another site, and I can very well place an RP on that site, either on site 1 or site 2. Okay, so there is a current limitation is that we cannot configure RP on a VTUP, RP on a VSX border routers. So that is one of the limitation. So I'll go through that in the coming slide. So IP ping spots VSX virtual neighbor need to be configured on both primary and secondary. So most of the use cases will be something like this. We have a regular site where you want to connect to via an SVI or via an ROP. or if you have a pure L2 router, that is also possible. Okay. Next use case. This is another use case where you have your active VLAN gateway IP. Basically, you can configure the same IP on your border gateway for all the host and receivers, right? You can configure the same IP on both the primary and secondary. So this is also supported. So if you remember regular PIM, we don't support this, right? But for the VXLAN use case, right, we are supporting this. So this is the configuration for that IP address, same IP address, and the VXX virtual neighbor. So working principle is again the same. Both will act as DR, and both of them will send join, and the stream will either come via through the primary or via the secondary. So this is the active gateway case. Okay, now going to the caveats, what we have is so our current implementation is I said no, it's all proprietary, and it is not using the EVP and route type 6, 7, and 8. So you cannot interrupt with other vendor routers. Okay, so that is a limitation. So this is applicable for both IGMP and PIM. So then IVRL again is not supported in 10.06. Okay. So this is specific, not specific to VSX. It's like it's a border caveats. So now going to the VSX specific caveats, right? So what we are supporting is L2 extension. Okay, L2 extension is supported, and SVA extension is supported. L3 extension to ROPs are also supported. So these are more like what we support now. It's I don't. Okay, so what we are not supporting is RP on the VSX switches. So this is very important to note down that no, the RP is not supported on this release. We are planning to support in the upcoming releases. So then another thing is that no, I said like compared to snooping, right? The routing case, it's a flood actually. So the traffic will be flooded to all the VTEPs on the L3 VNI. Okay, so we are planning to optimize that in the upcoming releases. So but for the first CP release, it is still it's not an it will be a flood solution only. So these are all the basic limitations, majorly the RP and the flood optimizations. These two are the limitations currently we have. Okay, this is the DC use case basically. I said so here in this topology you all have the VSX border gateway, right? So all are VSX. So where do you place the RP? So since we have the limitation, so the only possible way is you have to configure RP connected to the another interface. Okay, so you have to extend a border leaf router and configure RP on another device. So that is another caveat we have because of the RP limitation. And this is again, we don't have any specific caveats here. Again, the same caveats only. RP cannot be configured on the VSX cases. So if you have a limitation like that, you can probably go with the VSF solution on the instead of the VSX scenario. But the RP support will be will be provided in the subsequent releases. So I'll give it back to
yeah. You can stop sharing. I'll share mine. Okay. Configuration wise, How you configure IGMP snooping? It's at the VLAN level, you can see here, right? Just one command per VLAN. So you, for example, this is VLAN 10, you enable this on all your VTAPs. So you can't actually see to prove, you can't actually prove IGMP snooping is working unless you actually snoop it to do a capture on the uplinks. I'll show you later on what this looks like to prove that IGMP snooping actually works. Yeah. So this is the one we said about for data center, right? Because data center, everything is VSX. So you can't enable your RPs there. You can do an external Anycast RP. And this is what it looks like on the RPs. It could be an existing network, just single RP, that will also work, right? Anycast is for HA. If one fails, you still have an existing RP. So you have unique loopbacks here, loopback 10, but you have the Anycast loopback 11 here, for example. 200.8 is the RP that you want to point to on all these VTAPs. So that's the MSDP Anycast RP on the external world, external network that you want to point to. Okay, and on VLAN 10, you can see here, I have the active gateway and also have the physical IP. So that will support the same IP in future once you release it in CPE. And you basically configure the RP at the VRF for router PIM. So each VRF needs to have one RP at least. You point it statically to the external RP. This is how you verify your neighbors on that VRF. You can see here, because it's a VSX, you have a neighbor on the other VSX, the secondary on VLAN 10. You also have a neighbor on the L3 VNI towards your remote VTAP. And if you do show IPM route for the VRF on leaf 1 here, for example, this is the source and the group is 239.10.10.10. Okay, you can see the source here, 10.12 is the source. Incoming is VLAN 10. So this is from the leaf 1 perspective. Incoming is VLAN 10, outgoing is the L3 VNI that's forwarding. So you can check the RP using this command per VRF. On leaf 2, you can actually do the same show IPM route. You can see incoming is now L3 VNI, coming in, L3 VNI. You can see the S, G, the source 10.12, and the group, multicast address. Outgoing is VLAN 12 towards your receiver. That's how you verify your L3 PIM forwarding and your PIM RP within the VRF as well. So in environments like the campus where you have VSF switches, you can actually use VSRs in the overlay. There's no need to point to external RP. So this is how you configure it in the overlay. VTAP 1 here on the left, VTAP 2 on the right. Okay. And basically in the PIM of the VRF, you specify RP candidate. So this RP candidate will be unique IP, right? You can see loopback 3 is 60111. This is also unique 6211. So if it fails, right? If this VTAP 1 fails, remote VTAPs will have both. It will just reuse whatever's available. If this goes down, it will be removed. Right? And basically what we're trying to say is this RP is going to be RP for the 224/4 range. There are also BSRs using this unique IP. So they're both advertising and functioning as the RP in the overlay. So this is how you achieve redundancy for BSR and RP in the overlay. How you check it? You can see here. You can see that both are RPs for the same group. So it is load sharing, right? So both will become RPs to share the groups. Best practices. Okay, hand over back to Thomas. Right, Thomas, share screen.
Yeah.
Yeah, we see it.
Yeah. So okay, so for IP IGMP snooping, okay, so the requirement is that the full mesh tunnel connections are required. Okay, so just ensure that no, all the VTubs are connected via full mesh tunnel configuration. And the second requirement is that the redistribute local SVI. This is required to be configured on all the VTUP. This is required to learn the courier MAC address. Okay, so this is a requirement for IGMP perspective, and on a VSX, okay, so on a VSX, it is required to configure the robustness, IGMP robustness to a higher value. Now, this is it's a regular recommendation for all VSX. So the same recommendation is applicable here also. So this is just to maintain the join for a longer period, so that the traffic disruption during courier reboots will be be reduced. So these are all some of the basic requirements and the good things to do with IGMP snooping. And for PIM SM, so again, for SM also, the full mesh requirement tunnels is a must. Okay, so then just like I said, no, the keep alive interface need to be configured and kept operational for a VSX, and it is recommended not to enable PIM on keep alive interface. You need to configure the keep alive interface, but PIM should not be enabled on the keep alive interface. So that is a recommendation for this thing. And and on VSX, the PIM active feature that is not supported. So you can see some laws and all when you do VSX primary or secondary reboot. Few drops or something like that we can see because active is not supported. And another command which we mandate is the VSX virtual neighbor, right? So this is a new command introduced for VSX case. So this I already covered. So this command need to be configured on the border VSX routers. And the EVPN command virtual MAC, right? This need to be configured for PIM-SM. So this is required for the register. I covered this again. I covered this already, right? So the virtual MAC is needed to be configured on all the VTUP. Okay, these are all the best practices you can follow. So to troubleshoot, so for IGMP, there is nothing like new troubleshooting tips or anything. It's all the same troubleshooting what we do for the regular snooping. So the exception is like you have to just ensure that the tunnels are operational and you have the unicast reachability. So these are very important because IGMP, being IGMP or PIM, control packets, they are always encapsulated and sent over the overlay tunnel network, right? So eventually they are all unicast packet which is going out on the tunnels. So if that connectivity is broken, you will see neighborship lost or a join drops, and also just ensure that that tunnels are operational and courier elections are proper. Okay, all router should know that the courier IP is the same and or who is the courier. So then check the joined VTUP tunnel. I mean, what all the tunnel interface which are for joined for a particular group, right? So this is very our classic debug command, show IP IGB snooping VLAN and group. You will see the list of VTUPs which are joined for this particular group. So if the VTUPs are not listed, right, the interested VTUPs are not listed, that means we have a problem there. So that's how you can see the traffic issues. Then if it is just used for routing, like IGMP routing only, that is like we have not enabled the snooping, so you can type in show IP IGMP interface and VLAN X, right? So that will tell you where is the courier and who is the courier, all those things, all those details you can see here. Then another thing is that we can look at for the courier detected port, which is the VTUP where the courier is detected. All those things will be the same like what we are supporting earlier also. So another thing is that we can monitor the join uptime. So the previous command, right, the join show IP IGMP Snooping VLAN X group Y, that will tell you the join uptime. Okay, so how long this join is been up, and if you see any fluctuations, right, so you know that the client dropped out for some time, and and the last one is like we can look for the COPP drops, IGMP COPP class drops are there or not. So this is very important, right? So if on a scale setup, if you are seeing IGMP, a lot of IGMP reports are coming and the COPPs are dropping it, right? So you bound to see issues with those ports, right? Because the joints are missed. So now let's move to the PIM SM troubleshooting. So here we have to see the interface is again operational. Show interface VXLAN VTUP. This need to be operational, and so typically you will have more than one VTUP. So just monitor, just ensure that no, it is all operational, all interfaces are operational, and verify that the PIM neighbor exists. So on each L3 VNI interface, you will learn all the neighbors, right? So VTUP 1 will learn VTUP 2 and 3. So show IP PIM neighbor on the tenant VRF, you will see the neighbors, right? So if you see the notice here, no, the VNI, this is the interface on which the neighbors are learned. So if there are 222 and 333, so you will see both the neighbors learned on this particular VTUP L3 VNI. Next is the BSR and RP information. So again here, either when the BSR is outside the fabric or inside the fabric, so the entire tenant VRF should have the BSR IP, the same BSR IP and the RP information set. So what we can do is our regular command, right? The show IP PIM BSR VRF red. It will tell you who is the BSR. So within the fabric, outside the fabric, everybody should point to the same BSR, and then come to the RP information. So every router's information about the RP need to be consistent, right? So we can check this RP information need to be the same RP, right? Learned by all the router. So if some router is not learned, right? So basically we have to see the route to reach the RP is there, okay, or route to reach the source is available, route to reach the EBSR IP is there. So if there is any problem in the overlay tunnels, right, to reachability, the respective VPN reachability, then you may not you may not see these information getting updated or anything like that. So just ensure that your unicast reachability is all fine for this particular IP, these IPs, right? And then verify that no, it is learned or not. Okay. So this is what I have covered here. So the unicast reachability, being its EBSR, RP, the multicast source, or the DR router. So all these router need to be reachable via the overlay route. So what you can try is show IP route BGP VRF route, that will tell you via which tunnel it is learned, right? So which VTUP it is learned. So so this is something what we can check if it is over the tunnel, right? So the should be learned by the NCAP VXLAN and via this particular tunnel.
Hey Thomas, question on the snooping robustness. You recommended that, right? Is that only for VXLAN? The question coming in.
That is for not just for VXLAN, that is for the VSX in general. So if you have a VXX topology, right, so the robustness is can be configured to a higher value. So this will avoid the traffic disruption when the primary router, being the courier, if it is going down. Poor is the courier, that the courier is going down, right, and that that immediate courier switching issue, so that can be optimized using a high robustness value. So this is a general recommendation, yes, not just for a VXLAN.
Okay. If it's general, maybe you can look into changing the defaults, right? Look at it as
yes. Yeah. So basically that is for a VSX only. So that's what. So on a VSX, right, the interface which are where the clients are connected, right? So that is not something which we explicitly tell that this is a client VLAN, right? So in that sense, right, so the user need to configure this. So that is how it is recommended.
Okay, so let's move on to the demo next.
Yeah. Yes.
Running out of time, so you can stop sharing. Let me share.
Yeah.
Okay. Demo here. Okay, this is the demo topology. I have VSX on the left, VSX on the right, source VLAN 10, receiver VLAN 12. Okay, the middle is just the route reflectors, not non-VTAP. It's distributed gateway. So I'm going to show you IGMP snooping first. Okay, IGMP snooping.
Yes.
Let's see here. Here, okay. So this is my VM on the left, right? So right now, if you go to sniffer, let's run it. You see all the multicast running. Okay. So let's enable IGMP snooping, and we shouldn't see this anymore on the uplinks. If we go to here, it's going to be at VLAN level, IGMP, IP IGMP snooping. Okay, enable on both the VTAPs. Right, enable. Then if we start our Wireshark again, we shouldn't see that anymore on the uplinks. Yeah, so you don't see. So it's been filtered off, right? So that basically optimizes your underlay network. So that's the first demo. IGMP snooping, enable for VLAN 10, because there's no receiver here, right? So you wouldn't send out. But once we have a receiver on VLAN 10, you would see that traffic. So next, I'm going to show you a layer 3 multicast and MRoute between a receiver and a different subnet. Okay. If we go back to our VMs, this is my receiver. Okay, I'm going to start. You can see it's on, this is 12.11 IP, different subnet. Start. But before we start, let me show you before and after. Okay, here, show IP MRoute BRF, VRF1. You can see there's a source, but it's not sending an oil list. There's no outgoing interface. If you go to the other switch, here, there's nothing, right? There's no MRoutes because there's no active. So let's start it. Open stream. Interested in this group. Okay, it's working now. You can see multicast streams happening on this. Okay, so let's look at the configs again. This is your source. What happens is you can see now there's oil list for the L3 VNI is forwarding on the receiver. You see incoming L3 VNI. You should have outgoing, maybe on the other VSX switch, right? Because it's a VSX pair. So outgoing VLAN 12. Yeah, should be on the other one. Okay, let's look at the capture. I mean, our Wireshark as well. We should see multicast traffic flowing. Yeah, you can see it's running, right? So that's layer 3 multicast. All right, Thomas, want a remote control?
Yes, sir.
Okay, let's do 5 minutes more of this, then we can end this session.
Okay, so basically what we have to see, the tunnels are operational, right? So show interface VXLAN VTAPs. So here we have to ensure that those L3 VNIs are operational, right? And just like the regular interface, right? There are neighbors learned or not. Show IP PIM neighbor. Okay, so there are we can see the VTAP on a VNI 1000, right? The neighbors are learned. So this is the particular neighbor which is requesting the join. Then what we can see is the BSR information.
Or running
This is a
BSR.
static.
Yeah, static.
Okay, this is a static RP. Okay, so let's see if you have configured the BSR on a non-VSX router, right? You can see that BSR IP here. We can very well configure BSR on VSX pair also. So the only limitation is that RP is not supported on VSX. Okay, and you can see the RP set learned or not. The static RP show IP PIM RP set VRF VRF1. So this is the RP set information on this particular VRF. And the mroutes just like show IP mroute VRF1. Yes, so so basically it is receiving the traffic on VLAN 10 and getting forwarded on this L3 VNI. So let's move to the secondary device, the other VTUP, not the secondary, the other VTUP.
Yeah, correct. That's the one.
This is the one.
Yeah, three is correct.
3. So this guy have learned the remote neighbor, which is the VTUP1. And you have a static RP also here. So IP ping, RP set, VRF. So again, the same via RP IP here also, and the mroute information. IP.
Yeah, looks like outgoings on the other secondary VSX of this rack. So we don't see it here.
Yeah,
okay. But this is expected, right? On a VSX pair, only one will have the outgoing, correct?
One will be having the outgoing.
So this is correct. Yep.
This is a primary, secondary. Okay.
This is the primary here.
Okay. And so another thing is like show.
Maybe Daryl, we can do a show IPPIM RP set VRF VSX peer. So that
show
we can
IPPIM. Show IPPIM RP set. So basically, these many comments only to verify that. So our regular PIM diagnostics and all still applicable here. You can, if you want to see the shell commands, right? So we can refer the wiki, the multicast debugging wiki. So the same debugging we can apply here also. So Daryl, you can take back the control.
Okay, thanks everyone. We just went over a little bit. So I hope that was useful. Thanks for your time. Ruben, anything else you want to add?